In our last video, we took a look at evaluating inverse trigonometric functions, sine, cosine, and tangent. In this video, we're going to work with their reciprocal, so the inverse cosecant, the inverse secant, and inverse cotangent. So to do this, to keep it relatively simple for our purposes, we're going to rewrite these using their reciprocals. So we know that the reciprocal of cosecant is sine. So we're going to rewrite this problem as the inverse sine of. Well, when we do these, we have to make sure that not only are we doing the reciprocal of our function, we also have to make sure we do the reciprocal of our x value, because these are ratios, this time side ratios, and so these ratios need to flip as well. So the reciprocal of 2 is 1/2. I see a lot of people forget to actually do the reciprocal of the x value. So instead of evaluating the inverse cosecant of 2, I'm going to evaluate the inverse sine of 1/2. It'll get me the same answer. So first question, like before, is our x value within the domain? In the domain of inverse sine, recall, was between -1 and 1. Hopefully you have those notes in front of you. So yes, it's in there, which means I can look this up in my chart. I should be able to do this just fine. So going to our sine column and looking for a sine of 1/2, I see it right there. My missing angle must be pi over 6. And since everything's positive, I don't need to worry about adjusting or changing quadrants or anything like that. My angle is just pi over 6. That is my missing angle. I can check this using a calculator, although I don't have an inverse cosecant button. So really what I'd have to do is just check, is the cosecant of my angle equal to 2? So I'd kind of have to type in a little bit something different. I'd have to type in 1 over the sine of pi over 6. That's the equivalent of typing in the secant of pi over 6, or cosecant. And I want to see if that comes out to be 2 on my calculator, and yes, it will. So there's my answer, pi over 6. Okay, let's try one where we do have to do a little bit of angle adjusting. So the inverse secant of negative square root of 2. Well, first step, switch inverse secant to inverse cosine. And then don't forget to do the reciprocal of your x value as well. So I end up with -1 over square root of 2. Now before I go looking for that value in my chart, or looking for the positive value of it, I don't want that negative, or that square root in the bottom. So recall, what I would do is I would multiply the top and bottom times square root of 2, which gets me a new angle, an angle that actually will be in my chart, of square root of 2 over regular 2, the negative version of that. So that's what I'm going to look up in the cosine column. So when I go to cosine, I won't see a negative, but I'll see a positive version, so right there. And so I can read backwards and see that the angle I'm looking for is somehow going to involve pi over 4, but that may not be the angle itself. So looking back at my problem then, here's what I know. My angle is somehow going to involve pi over 4. And since the angle I have is negative, I need to look at where cosine is going to be negative. So let's make a quick sketch to see what's going on here. With inverse cosine, recall that I'm only allowed to pick from these top 2 quadrants. That's what we agreed on. Cosine is positive here. Cosine is negative over here. So I need to draw my angle in quadrant 2. So let's go ahead and draw pi over 4 as my reference angle between the x-axis. However, I need to always measure from the positive x-axis around. So it's not pi over 4 that's my answer, it's this missing angle over here. Well, if we recall that this would be 1 pi, if I go halfway around the circle, this missing piece must be 3 pi over 4. Okay, so there's my missing angle this time. So the inverse secant of negative square root of 2 is 3 pi over 4. And one last example, that's going to be our cotangent one. Now cotangents actually get a little tricky. I have a note at the bottom about this. To keep it simple for our purposes, we're just going to worry about cotangents in quadrant 1, where our cotangent's positive. That way we don't have to worry about any of this crazy business at the bottom. So let me, again, start the same way. Instead of writing inverse cotangent, I'm going to write inverse tangent, and then make sure you do the reciprocal of your x value. Well, 1 is special. 1 is its own reciprocal. If you see that and flip it, it's still 1. So all I need to do is find the tangent of 1. It's positive, so that should be straight from my chart, no issues. If I look up in the tangent column, where my x value or my side ratio is 1, I can see that that missing angle is again pi over 4, but this time there is no adjustment required. It's in quadrant 1, everything's positive. Pi over 4 is my missing angle.